G'day folks, just for a little late night, Saturday night autopsy, I thought I'd show you the components of a carbon dioxide fire extinguisher. Apart from the liquid CO2, which I don't have on hand, it's a little bit empty. But starting with the cylinder itself, it's a nice heavy wall aluminum cylinder, probably 1/4 to 3/8 of an inch thick all the way through, probably 1/2 inch or so thick in the bottom, and almost 3/4 of an inch thick up at the top at the neck. Fairly extensive process in machining or extruding and then machining one of these cylinders. They're pretty good, rated to several thousand psi. This one's getting modified for compressed air only use. It's way out of date for recharge. It's not worth recharging, but I've taken the valve and everything apart for modification, and I just thought I'd show you what's what. Obviously got the handle and trigger on the top of the cylinder. The handle and trigger assembly pivots on a roll pin that's pushed through the valve body through there. We've got a safety pin, of course, to lock the two together when you store it. That there is a siphon tube that goes down inside the tank to the valve body. Obviously it feeds liquid CO2 up to the valve body, and there are a series of essentially jets and diffusers to turn the liquid CO2 into a spray, a very heavy white misty concentration of carbon dioxide. So you've got the main valve body there, that's the outlet, that's a pressure relief port, and the main valve screws in the top there, and that's what that is there, with the O-ring for the main valve body. But that is the main valve. You push down on the pin through there, there's the main pin and release valve and its seat. It's very simple technology. Nice copper washer and the main spring, which fits right down inside the guts of it. This is on the outlet side. That's what you screw the conical, I suppose you call it a diffuser or just outlet cone onto. Your traditional, this one has a hose on it, but this one here had a small conical fitting on it, whereas this one here has a hose. Very similar, but essentially the same principle. Not sure what that did. It was basically screwed into the guts of the valve right there, and I'm guessing it was diffusing or creating some kind of pressure differential to start evaporating the CO2, because then it still had to pass through this, which is a bit odd that they'd also have that in the way. Maybe just a restrictor, primary restrictor, secondary restrictor. And that there is the pressure relief in case of, well, overheat, fire, whatever. If the vessel is involved in a structural fire or something like that, instead of exploding like a bomb, this copper washer that I've perforated to remove would blow out and dump pressure through the holes in this plug. So when I removed this, it was domed, like it'd been under pretty intense pressure, but it wasn't ruptured. The holes are from me trying to get it out and piercing it with a screwdriver just to try and pry it out of the valve body. So that's what separates the liquid CO2, or just CO2 in general, from atmospheric pressure. If the extinguisher is overheated or overpressurized, that's what blows out. That's just a solid copper disc, and it goes pop and dumps pressure. So it's just pretty straightforward. It has got a nice high pressure valve body and a high pressure discharge valve with fairly decent flow. I like the flow rate on that valve. I'm going to be modifying the old pressure relief as a high pressure air inlet for a refrigerant compressor down there, and also boring that out to maybe 3/8 of an inch, whatever that internal diameter is in there. almost looks like 1/2 inch. So yeah, it'll involve some high pressure air and probably candy. Yeah, high pressure air and candy's always fun. And chocolate, airborne chocolate. Anyway, thanks for watching and stay tuned for more. I can't help but think this would be good for shooting Tic Tacs. We just solder into the outlet fitting like that. Tic Tac gun. Awesome. Thanks for watching.